Hello everyone and welcome to yet another recreational programming session with Mr. Zozin, where we're developing a retro 3D engine in web. You want to take a look at it? Okay, so you go to localhost 69 and you're greeted with this beautiful retro 3D engine. Look at that. It runs at 30 FPS. It's supposed to run at 60 FPS, but since I'm streaming, like I can't run it at 60 FPS. But trust me, fucking trust me, mate, it runs at least at 60 FPS. You can actually check it for yourself, right? So you can go to the description and find the link to the source code. There is also a link to the instance on GitHub pages, right? Sodding.github.io raycasting. You can find the deployed instance there and actually check it for yourself. I'm going to put that in the description. There we go. My end goal with this entire thing is to actually make a game out of that, something like a roguelike, but I haven't decided what exactly. But the only thing we're able to render right now is floor, ceiling, and the walls. Right now we have only one wall, but I can actually maybe extend and add more walls, right? So nothing really stops me from doing that. So let me actually find TypeScript. So I can like put a couple of things in here, like a TypeScript in here, then maybe a TypeScript in here, and maybe TypeScript in here. So I can do something like this. And right, so then as you can see, I have actually several walls in here. I can actually wander around, you know, between the walls and stuff like that. I can actually change the texture as well. Right, so I just had coded TypeScript because it's in TypeScript and stuff like that. Right, so but that's not particularly useful. We want to be able to have some sort of like items, right? So smaller items and maybe some sort of particle effects and stuff like that. So usually in this kind of like old school raycasting 3D engines, they are indicated with sprites. Right, so we're going to be continue following the same tutorial that we followed like before. Not really following, right? Because this tutorial is so obtuse that I can't imagine myself like actually following this tutorial. So what we're going to be doing, we're going to be getting inspired by the tutorial, right? So here they kind of have a recipe on how to render the sprites, and this is just like a 7 points in here. We're going to read them and try to get inspired and try to implement it ourselves, right? And the sprites usually in that 3D space, they look kind of like this. You probably, if you ever played like a Doom, the first original Doom, you kind of know what I'm talking about. Like these sprites, they 2D, but there's a place, yeah, it's called Billboard. Yeah, somebody in the chat actually knows, right? So they're kind of 2D. But they are located within the 3D space and they're always rotated towards you, right? No matter where you're looking at them, they're always like rotated towards you. And this is because they're not rendered in 3D perspective, right? So they're sort of like not really 3D object. They're more like an indication of 3D object, right? More like an indication because they're easy to render. All right, so, and the fact that they're facing towards you like constantly is actually like a side effect of not like doing a proper perspective or anything like that. You just slap it on the screen and that's why it appears constantly facing towards you, right? Because you don't do anything about that. It's kind of actually interesting. So yeah, once we have a mechanism within our engine to render these kind of sprites, we can have items, maybe some sort of a collectible items within the game, and also we can use the sprites as particles. So that means we can use them as bullets, right? So for example, maybe you're shooting something, you can use them as enemies, right? So all of these dynamic entities that move around that are not really part of the environment, they could be denoted as sprites. Right. So, and I think it's a really valuable mechanism for these kind of sort of like games. And that's why I want to implement this entire thing and add it to our engine. So let's actually read how you're supposed to do that, right? So we already know how to raycast walls. We know how raycast floors and ceiling. How the fuck do you raycast sprites? Okay, so while recasting the walls, store the perpendicular distance of each vertical stripe in a 1D Z buffer. This is a very interesting point. So do you guys know what is a Z buffer? It's kind of an interesting concept, right? So it's usually used in proper 3D. And essentially, whatever you see on a screen is called color buffer. So essentially, it's a buffer that contains colored pixels, right? So parallel to that color buffer, quite often in OpenGL or any like graphics APIs or anything like that, there's so-called Z buffer. So it's a buffer of the same size as the color buffer, but instead of pixels, it stores a single floating point value, the Z value, the value in of the Z coordinate. So the question is, the Z coordinate of what is it storing? The Z coordinate of a pixel. Look at that. So you can look at this sort of surface, and you notice that this surface, this side of the cube, is sort of like tilted. The actual Z value of this pixel on this edge is actually closer to you than the Z value of that pixel on that edge. And Z buffer literally stores a Z value of each and individual pixel, usually in OpenGL. We're talking about OpenGL, by the way. I'm not talking about the actual raycasting or old school raycasting. Like generally in 3D graphics, this is what Z buffer is called. And what is it used for? It is used for determining which pixel is visible and which pixel is not visible. Right. For example, you may have two polygons that are intersecting each other. How do you render them? You need to know the Z coordinates of each individual pixels to actually create some sort of a seam. We actually look into the Z buffer mechanism in Olivet's series, I'm pretty sure. So let's actually open it. So let me open this entire thing. So I'm gonna put that in the chat, and also for people on YouTube, I'm gonna put that in the description. Right, so here's that, and we have a little bit of a proper 3D in here. There we go. So here's the good example. So you have two polygons that intersect each other, and to create this seam, we actually used a Z buffer to know which pixels to draw and which pixels to throw away. Right, so we can actually have like textures in here as well, right, as you can see. So there is a little bit of a texturing in here and stuff like that. So that's what Z buffer is. So here they're talking about one-dimensional Z buffer, which is rather interesting. It's a one-dimensional Z buffer. So, and this is because we are raycasting the walls in a one-dimensional space. Right, so we have a position of the player, right? So maybe I'm going to start my paint and draw this entire thing yet again, right? So I think it's going to be very useful to draw that. Okay, let me do that. So the way we raycast, so here is the position of the player. I'm going to denote it as PP, which stands for the position of the player. Then we have a certain FOV, field of view, right? So this is FOV angle, right? And this is a P1, and this is P2, right? So and we have some basically projection plane or nearest clipping plane or something like that, whatever you call it, right? So here is an obstacle, and basically from the PP, we are shooting the rays in all of the directions for each individual pixel column on the screen. So this is the screen, by the way. So this is the screen, like this. Right, and then if it hits something, we actually color the column associated with like this specific ray in a corresponding color. Actually, we put a column from the texture because these things are usually textured. So because of that, what we're doing in here, we haven't like a one-dimensional Z buffer, right, which stores the distance to the column of the obstacle we're rendering. Since walls are rendered basically in one-dimensional space, and the height of the wall is sort of guessed based on the distance from the player to the obstacle, we don't really care about the second dimension, we only care about the horizontal dimension. So because of that, the distance buffer that we're collecting, it's one-dimensional, right? So project your PP to Z buffer. How am I supposed to have any serious conversation with this chat? I'm really curious. Anyways, okay, let's continue projecting our PP. So, okay, so this is, I suppose, what they mean. You do, you know, raycasting, And as you raycast for each individual column, you sort of like a saving Z buffer, right? You sort of saving Z buffer. I wonder if we can like right away already implement that. So it shouldn't be that hard to implement, I think. So let's go ahead and just for this entire thing, implement the Z buffer. So we need to go into the game TS, and interestingly, this becomes kind of a part of the state of the game, but the state of the game here is player and the scene, right? It would be nice, honestly, to maybe introduce some sort of an interface called game, and this is where we're gonna have the player, this is where we're gonna have the player, this is where we're gonna have this scene, like that. And on top of that, we probably could have like a buffer, right? The Z buffer, which is going to be array of numbers or something like that, that we could reuse. So as of right now, we also pass a lot of things in here, like a back context and back image data and so on and so forth. So I'm not really sure. So Z buffer is more like a thing that belongs to the display, right? So we have a lot of things in here, like a 2D canvas, right? So the off-screen 2D canvas and the back image into which we're rendering all of that. So, and I feel like maybe this kind of stuff has to be moved into separate entity that we would call something like display. I think that would make more sense because you render in a game into the display, right? So let's actually go ahead and do that. So, right, interface display, and in here we're going to have the canvas context of the canvas that is visible on the screen. So that's the context of this entire thing. Clean architecture, yeah. So we're going to be doing clean architecture. So the back context is the back canvas into which we sort of buffering everything. And back image data is the image data that stores the actual pixels of this like sort of canvas and stuff like that, right? So this is what we want to have in here, right? And essentially we want to get rid of this entire goop and replace it with just display, right? So in here we accept display delta time, how much time has passed since the previous frame, and the state of the game, which is the state of the player and the state of the scene, right? So, and all of the technicalities of rendering should be stored in the display, right? So all the context, canvases, buffers, and stuff like that, including Z buffer, right? Including Z buffer, which is going to be an array of numbers. Maybe it would be even better to store it as something like a float 32 array or whatever, right? So because there are things like that in JavaScript, but I don't think I want to do it right now, right? So I think it would be better to just say this is an array of numbers, right? Okay, so that will obviously cause compilation errors, right, and stuff like that. So let's go to 512, 19, I mean, and let me maybe fly check mode this entire thing. Okay, so does it complain? I don't really see the errors. Let's go to the next fly check next error. Didn't I just enable? I enabled, but it doesn't really show me errors. Okay, so let's actually go in here. Okay, so here in CTX, what we have to do, we have to just do display CTX, right? So this is the canvas size, and we just do display CTX. So 520. I'm surprised that this thing doesn't work. Something with the fly check. Disabling backend because can't find suitable init function. Okay, maybe I just need to restart Emacs. So one day I said that if LSP for TypeScript breaks, I will do nothing. I think the time has come. I think it finally broke, right? And I'm supposed to not do anything about that. Right, so let me see, and next error. Yeah, so I guess it broke, and I'm not supposed to be doing anything about that. So flight check mode, next error. Yeah, so it's not working anymore. Interesting. Well, that's fine, that's fine. So in here, I suppose one of the things I have to do is query replace CTX with display CTX, right? So we can try to do that. So it's going to be that, no, that, no, that, that, that. Okay, so what other things we have in here? 523. So this is the back image data, right? So let's do back image data. Replace it with display back image data, right? So and in here we're gonna just replace it all like that. So which is also rather interesting, right? So maybe we should now pass you know, the entirety of the display to these functions, right? But maybe not. I think it's fine to actually keep it like that. 527. Okay, so this is back CTX, right? So and I'm gonna do back CTX display back CTX, right? So let's replace it like that, and boom. All right, so everything is compilable except index.ts, right? So it's 97. I said 97. Thank you very much. Okay, so and in here we have all this entire group, right? This entire group of the parameters. We have to replace it with display. So maybe one of the things we can do in here, by the way, we can create const display, which is just that. I wonder if we can just do things like this in JavaScript and in TypeScript argument. Right, what if I is not assignable to parameter display, so it's more like 98. Yeah, so I have to explicitly maybe say that this is a CTX, then back CTX and back image data. I suppose, oh, I think I've just forgot to initialize the Z buffer, right? So Z buffer is supposed to be empty, and that works. That actually works. So it's kind of like, I kind of purely guessed that you can do this kind of stuff in JavaScript based purely on how Rust works, because you can do this kind of shit in Rust, right? So yeah, it's kind of useful to know several languages, right? It's useful to know several languages because you kind of know like a lot of different ideas that other languages may start adapting and stuff like that. So yeah. So anyway, let's take a look at the subs. Who subscribed? Who subscribed? Trova Ozinho, I hope I pronounced your nickname correctly. Thank you for Twitch Prime. And LimeXS, thank you so much for Twitch Prime with the message Atsoding Apoging. CodeCat69, thank you so much for Tier 1 with the message It's been 9 months. We finally got our Twitch baby. Finally got our Twitch baby. So yeah. Okay, so everything seems to be compiling. All right, so if I, okay, so it automatically refreshes, as you can see. It automatically refreshes, which is kind of cool. So now, what I'm thinking is that we have to actually allocate, you know, the Z buffer equal to the size of the width. So I keep forgetting how you allocate array in JavaScript. So let's quickly, let's quickly remind ourselves, right? So I think it's a, yeah, okay. So, and then we probably want to fill it with 0. So, all right, let's go ahead and do that. So it's going to be array of the size of, so if it's a bag, it has to be screen width, right? So it's a screen width, and we just fill this entire thing with zeros. Does fill return that? Yeah, it does return this, right? So which allows us to create this object and instantaneously in place modify it. Right. By the way, speaking of this paradigm in JavaScript where you create an object and you have a bunch of builder methods that instantaneously modify that instance and return this so you can chain them, I recently refactored off-screen vector to dvector to be like that. Right. So we talked about it, but I actually went ahead and refactored the vector. So vector 2. So where is that? There we go. So as you can see, majority of the methods, like add, they do not create a new instance anymore. They do not create a new instance anymore. They actually modify this thing in place and return this. Right. So I tried to minimize the amount of news used in the vector. And if you do need to create a new instance of the vector, you have clone. Right. So you call clone. And then you in place modify the instance of that cloned vector. So, and that creates a very interesting situation that the actual clones become obvious, so you can grab for them, right? So if I want to optimize performance, I just search for clones. Okay, where we have clones in here? Okay, so here we clone things, and then here we just use things in place. If I want to optimize something, I will probably start from here, Right now, I don't want to do that, right? So, but at least I know like low-hanging fruits, what to optimize and stuff like that, right? So, and as we discussed earlier, you really don't want to create a lot of small objects on each frame, right? Because the GC starts to chug because of that. Right, so it's actually very useful, and I stole that idea from 3JS, right? So if you Google up 3JS, 3JS vector 2, this is literally what they're doing in there. This is literally what they're doing. So this is their documentation, right? So it's just a documentation website. And their entire paradigm is just that. So all of the operations here are in place. And we can even take a look at the source code. I think source code is available in here, right? So it's basically like roughly the clone of the 3JS vector, right? So as you can see, set scalar. So they have clone, just as I do, and add also just modifies all of these things in place. If you want to read about this kind of thing, I'm going to copy paste it in here. In fact, I'm probably going to add it to the description, right? So let me grab this entire thing, and I'm going to go into the description in here and just append it in here, because it was heavily inspired by that. It was heavily inspired by that. So let's close this entire thing, and yeah, so that's what's going on. So we have the Z buffer. We have the Z buffer, and now when we're rendering the walls, we want to fill that Z buffer with the distance. Like, but what distance? The orthogonal distance, perpendicular distance to each vertical stripe in 1D Z buffer. Yeah, so they deliberately using the word perpendicular, right? Because here you can have two distances. So here is the first distance. It's the distance from the place where you hit to the position of the player. And if you use that distance for rendering, you're gonna end up with a fisheye effect. We can take a look at that. Like, I wonder if I can quickly reproduce this kind of thing. So this is the distance that we use. If we, so, and this is RGBA, if we replace this distance with the distance to the player, so this is where we sort of hit. So P, yeah, P is the place where we hit all of that. So what we have to do now, we have to take the player position, and just take the distance to P. So the cool thing in here is that no cloning of the vectors occurs in here, right? So everything is computed in place. And if we just look at that, you will notice that there is a little bit of a fisheye effect. It's so visible, you can actually see that in here. So it starts to curve in here, right? It starts to curve. All of this, yeah, this is actually kind of funny how it just like warps around and stuff like that. So this is the fisheye effect that I'm talking about. Right, so this is the fisheye effect. If you just use that in like distance directly. So because of that, the distance that you must use is orthogonal distance actually. So imagine that you have the second, you know, plane in here that is parallel to the projection plane, and instead of using distance to the point, you use the orthogonal distance, which has like a 90-degree towards that, and that gets rid of the fisheye effect. Right, so if you just do something like this, as you can see, just a second, boom, it got rid of the fisheye effect. We do have hot reloading, by the way, right? So we implemented that on the previous stream, and that allows me to do this kind of shit very quickly, relatively quickly. So as you can see, now we have a fisheye effect, right? So it's very much visible in here, and then I can just swap it around. Right, and the fisheye effect disappears. Can you see do that? I don't fucking think so. Dub. You see is not a dynamic language. It's very easy in dynamic languages. Yes, says the guy who implemented hot reloading in C, by the way. Honestly, all of these so-called tech arguments literally look like that for me. They're fucking stupid, right? If you know how computers work, if you know how tech works and stuff like that, all of these arguments like this library versus this library, bro, I can fucking implement this library. I literally don't give a shit. It's just like, in participating in these arguments, it's just like, oh my god. What happened to the FPS? That's a good question. I'm streaming. That's what happened. We can try to improve it. Okay, so we can try to improve FPS. Specifically while I'm streaming, I'm gonna put 20 in here. So that will actually refresh the entirety of this thing. So that kind of improved. Like we can even put 10 in here. Sure. We can probably even put 10 in here. Now we have 30. Now we have 30. That's pretty progress. But I mean, it's like it's still pretty bad. Right, it's still pretty bad. Probably because I also have like my paint. Maybe if I remove my paint, like close my paint, maybe it becomes better. Okay, it actually became better. But I mean, this is too low resolution for my taste, honestly. So let's actually bring it back. So this is fine, right? So anyways. What we were doing, so I was talking that we're supposed to actually save in a Z buffer the perpendicular distance. Perpendicular, right? So that's what we're supposed to store in there. So let me see, render walls, and that perpendicular distance is basically this. Yeah. So we're iterating x, as you can see. So that means after we did all of the ray casting and shit, what we have to do is just take the display. We don't even have a display. So let's actually refactor this entire thing to accept the display. Let's go. Right, so, and now what I have to do, I have to query replace image data with display image data, like this. That's a lot of things in here, but I guess that's fine. So what other errors we have in here? So 384. It's not really image data, it's supposed to be back image data. Okay, so back image data, boom. Are you happy now? Yeah, you're happy now. 527. And in here, we just pass the entirety of the display in here. All right, that's cool. So now we have the entirety of the display. That's fine. That's totally fine. And essentially, so now what I'm doing is I'm taking the display, the Z buffer, and I'm just saying at X, store this specific distance. Store this specific distance. What's funny is that now, we always compute that distance regardless of whether we have RGBA or not RGBA, because we need to store it in the Z buffer. And maybe because of that, it kind of makes sense to reuse it. So essentially what I can say, query replace v.d with that one. So not replace that one, but do not recompute it like all the time. We kind of already cached that Z buffer value, just like, you know, just keep it. I think that's a reasonable thing to do in here. So is it okay? It's dead. Let's actually refresh this entire thing just in case. Does it even compile? It doesn't even compile. 3388. Oof, this one is interesting. So that means we want to compute V and D always outside of this entire thing. So it means we're kind of removing it from here. And we don't have to do that stuff in here. Okay, so a little bit of optimization, I suppose. So I guess we can live with that. Okay, cool. We computed everything in here, but it would be kind of nice to maybe see what's stored in that specific buffer, right? It would be kind of interesting to see what's stored in there. So let's maybe, once we're done finishing the wall, right? So this is where we rendered the wall. We're gonna just print the contents of the Z buffer. So display Z buffer, and maybe just crash the entire application. Just throw something like stop, right? So because I want to see that being displayed in the console. So let's actually open the console, open the DevTools. So do we have anything in the DevTools? We should have something. Okay, so here's the array. I would like to... Okay, so this looks fine. And as you can see, this is 15, which is over the limit. And that's very interesting. So it doesn't really tell me much. Oh, that's pretty cool. So it was actually going far, far away up until it stopped at 3. right, up until it stopped at 3. So I suppose this is basically the edge that it hit. It hit this edge. So that means this 3 now is growing, and then it hit 2 again. I suppose it hit like this part or something, right? So this is the Z buffer, right? So this is the Z buffer, and it tells us basically how far or close things are. Maybe we should actually kind of like somehow display this entire thing. I don't know, like overlay it. So essentially, if the value is too big, it should display it as small. How to say that? A small circle, some sort of a gradient. Yeah, maybe we should show it as a gradient. Maybe we should show it as a gradient. But I don't know how useful like knowing this thing will be. So let me actually see. So okay. So I can already kind of see that it is correct. So I don't know. So thank you so much, Ormus Buckster, for a 2-month subscription. Thank you. Really appreciate that. That's very epic. Okay, cool. So we get a Z buffer. All right, we'll get a Z buffer. So what do we do with the Z buffer next? Calculate the distance of each sprite to the player. Okay, so we need to introduce the notion of the sprite first. Right. Use this distance to sort the sprites from the furthest away to the closest to the camera. So they're using this old technique of just Z sorting. Z sorting, meine Freund. So they're using this technique of Z sorting. So essentially, you first render a thing that is further away. So the things that are closer are basically slapped on top. Right, so that's basically what they're using. All right, so, and why do you need 1D Z buffer in that case? Oh, I guess you need it in case a sprite intersects with the wall, right? So we don't have any Z buffering for the sprites among each other, right? So the sprites won't properly like intersect with each other, but they will properly intersect with the walls probably. I don't really know. But anyway, so we just do Z sorting, right? So we first render things that are farther away, and then the things that are closer away. Okay. Project the sprite on the camera plane into D. Sprite on the camera plane into D. Subtract the player position from the sprite position, then multiply the result with the inverse of the 2x2 camera matrix. Ooh. Project the sprite on the camera plane into D. Oh, and then colon, and this is the explanation of how you project the sprite on the camera plane. Subtract the player's position from the sprite position, okay. Then multiply the result with the inverse of the 2x2 camera matrix. Okay, so they're using some sort of a 2x2 projection matrix. So the 2x2 camera matrix. I don't really know it. I don't have any matrices in here because I just like project things manually. So I suppose what they're saying is that sprites are supposed to be projected as is, right? As you would do them in a proper 3D, I suppose. Oh, I think they even say that in here. The technique used to draw the sprites is totally different from the raycasting technique. Instead, it works very similar to how sprites are drawn in 3D engines with projections. Like in the points, sprites, and moving articles, only we have to do the projection only into D, and some extra techniques to combine it with the raycasting that is used. Okay. I see what is going on in here. Right? So they're projecting it like that. Okay, so you're projecting it on a screen, right? So you're projecting it on the screen. Then you calculate the size of the sprite on the screen, both X and Y direction, by using the perpendicular distance. Okay, I think I know what they mean by that. Right, so we compute the size of the wall using the perpendicular distance, right? So which is essentially this is the perpendicular distance, which is stored in the Z buffer, right? And we divide it by the height of the screen, and that's basically the size of the wall, right? So that kind of explains it. Okay, so draw the sprite vertical stripe by vertical stripe Don't draw the vertical stripe if the distance is further away than the 1dz buffer of the walls of the current stripe. Yeah, this is exactly what I was talking about, right? So essentially, sprites don't really properly intersect with each other, right? Because of that, we're using Z sorting, but they properly intersect with the walls, right? So this is sort of the limitation of the engine that we're going to have. All right, makes sense. Draw the vertical stripe pixel by pixel. Make sure there is an inverse color, or all sprites would be rectangles. Draw the vertical stripe pixel by pixel. Make sure there is an inverse color, or all sprites would be rectangles. I didn't get the point of this of this thing, but okay. Vertical stripe pixel by pixels. Make sure there is an inverse color, or all sprites would be rectangles. Invisible. Oh my god, I forgot how to read. I'm sorry. Okay, invisible rectangles, or all would be okay. So that makes sense because they usually have the like a background, the alpha. Yeah. So don't forget to support alpha. Fine. All right, so get some subs. Thank you so much, Droka87 for Twitch contribution with the message. Hello, Mr. Zudin. Hello, Mr. Droka. So Shinta42, thank you so much for Twitch Prime. Thank you. The alpha color, the sigma color. Sorry. Anyways, so I guess that makes sense, sort of. But I wonder what is this 2x2 camera metrics. Okay. So how to project the sprite on a screen is explained in full 3D rendering mathematics with 3D matrices and camera. For true 3D rasterizer or ray tracer 3D engines, and not explained here in the Raycaster tutorial. However, here it's done in 2D and no fancy camera classes used to bring. So we don't use any OOP apparently, no fancy classes or anything like that. To bring the sprite's coordinates to camera space, first subtract the player position from the sprite position. Cool. Then you have the position of the sprite relative to the player. Cool. Then it has to be rotated so that the direction is relative to the player. Okay. The camera can also be skewed and has a certain size, so it isn't really a rotation but a transformation. The transformation is done by multiplying the relative position of the sprite with the inverse of the camera matrix. The camera matrix is, in our case, plane X, plane Y. I have no idea what it is. Dir X, dir Y. I kind of have an idea what that is. I suppose it's a direction of the player where the player is looking, but what the fuck is a plane X and plane Y? It's probably explained in some other, chapters, but I didn't read them. And the inverse of the 2x2 matrix is very easy to calculate, right? So you just have that. Okay. So is there any demonstration of what is plane X and plane Y? Like where exactly? Like I need a picture, just to point where is the plane X and plane Y, and I can tell you where it is. Right, so we can take a look at the previous things. Plane X and plane Y is the screen. Oh, okay. So this is the previous chapter. This is the chapter 2, floor and ceiling. I'm gonna search for plane X, the 2D raster version of the camera plane. Okay, so there's nothing particularly useful in here. Maybe there is something in here. So where do they talk about plane X? I think something... Okay, so here is the direction, and okay, so here is the plane as well. So they have position, direction, plus plane. Probably the near plane. But, oh, okay. So, I don't know. I don't know. I need picture and just like arrow. this is plain X on the P. This is what I need. Like, this kind of stuff is not gonna cut it. Like, I don't understand unless it's just like a huge picture. Okay, here's that, go. This is what I need. But this tutorial is not gonna give me. Unfortunately, bruv, it's not gonna give me. The code presented below uses a small list of objects instead of a map. So this is a bad explanation. Like, it's easier for me to maybe figure out all of that stuff myself. All right, I think it would be easier for me to just figure out all of that shit myself, instead of just doing this inverse matrix. And matrices is like ultimate gatekeeping, because in reality, matrix does not explain anything. And this is the thing, is just like, I already ranted about it. Like, I remember, like, I really vividly remember that I already ranted about it. It's just like all of the tutorials is that, bruh, here's the black box. Just use it. Don't think about it because you dummy dumb. Don't look into the box. Just use it. Just multiply a vector by this matrix. Smarter people than you figure it out. Shut up. So it's always like that, because the matrix is just operations that you can explain these operations, right? They make sense, they have meaning, right? But the matrix is just a way to encode and compress this operation into a single matrix. And for some reason, people who give you that matrix thinks that it's sufficient enough explanation. It's just like, here is the black box, problem solved. And it's like, it's no better than just saying, like, use this library. It's just like, it's really annoying. It's really fucking annoying. It's really fucking annoying. But I like to understand things. So you're assuming people writing this tutorial know the math behind? Yes, I do. Because why the fuck you writing a thing, right? If you don't understand it. So I think that's a fair assumption, right? So it's a fair assumption that, like, you're trying to share your knowledge. You don't say explicitly that you don't know how to use this thing, so I assume that you understand it and can even reinvent it and reproduce it, but you don't do that. I don't know why. Maybe you hate me, maybe. So yeah. So yes. I think I need to make a small break, by the way. I think I need to make a small break because already streaming for 1 hour and I ran out of water. A Create React app. Right, so, and yeah, so let's go ahead and do that. So what's funny is that I think it's actually very easy to project. So let me just do my paint. All right, so essentially brush. Thank you. Okay, so here's the PP. So this is the PP. Here we have P1, right? So, and P2, they denote the boundaries of this projection thingy. So this is the boundaries of the projection thingy. You have a sprite, right? So you have a sprite, SP. Isn't that basically fucking find this point? Isn't that basically what the fuck it is? I think it is. I think it actually is. All right, so and for determining the size, we're just like projecting this thing like that, which is actually easier, honestly. Right, so which is supposed to be something like this, right? So you just find this point. Actually, no. So we have to find this distance, right? So we have the real distance and the perpendicular distance, and this is the one that we use to determine the size of the sprite that we're rendering. But ultimately, the position, the place where we're rendering this entire thing is determined by this thing. So we just need to find the intersection. Okay. So measuring his PP size on the string. Okay, let's make a small break. All right, so I think I understand what the tutorial wants. It's actually rather interesting. So let me demonstrate you. Let me grip my tablet, and maybe I'm gonna actually erase this kind of stuff. And let me C. So we do have the direction. Can I just have a brighter color? Thank you very much. Right, we have the direction. And we also kind of know the direction to the sprite, to the position of the sprite in there, right? And that forms effectively the right triangle. And where is the right triangle? Here comes the trigonometry, and we already know how to do the fucking trigonometry, mate. So essentially, we may say that these things are like, you know, I don't know, one-dimensional vectors, though I'm not quite sure about that part. Right, I'm not quite sure about that part. So if the direction is one-dimensional, right, if the direction is one-dimensional, maybe we can find the dot product between the direction and this thing, right? So there's this vector and this vector, and so let's actually think. So let's call it D. This is deer, and this is more like a, I call it the sp, but the sp is a point. So maybe I'm gonna call it sp minus pp, right? So we're gonna say sp minus pp, and we say, okay, let's actually find the dot product between that and direction. And the dot product, as far as I know, right, it relates cosine of this angle, right? So it's basically cosine alpha. So it's a cosine alpha multiplied by the length of this thing and the length of these things, if I remember correctly, right? So length of that, you know, sp minus pp, and the length of deer. But here's an interesting part. The length of deer is equal to 1, so we can kind of like forget about that. So it's only this, right? It is only this, which is totally fine. So yeah, so the only thing we want to do in here is probably maybe divide this whole thing, right, the dot product between these things, by sp minus pp. Those in doing some advanced math, bro, it's a school math. At least in Russia, this is considered like a school math. I'm not sure about the rest of the world, right? So but I remember doing this shit actually in middle school, right? It's not even high school math, it's a middle school math. So 6th grade. Not sure about the 6th grade, honestly, but when I was in school, the last math topic in high school that we had was linear algebra, actually. More like a half of the linear algebra. So we start learning linear algebra in like the last, you know, in the last year of high school. And then as the first like a year of university, this is sort of the first math topic that we study. So it's like stops at high school and continues in university, right? So it's kind of like designed like that. So half of that you learn in high school and the half of that in university. Linear algebra is, yeah, it's matrices, right? So we do study matrices in high school. Bloody communists torturing people with, but we're not communists anymore. Like, why people assume that we're still communists? In fact, nobody even fucking wants back to communism. A lot of people want back to Soviet Union, but that does not necessarily mean that they want communism. But that's already besides the point. Once a commie, forever commie. So you say people can't change and improve. So that means I can apply that logic to you as well and ban you and assume that you're never going to improve. That's a dangerous rhetoric you're using in here. It's a very dangerous one. So because it works both ways. Remember that. Works both ways. So we can divide that, and we have a cosine, right? So, and what is a cosine? Does anybody remember? So what is a cosine? So definition of a cosine. So adjacent to hypotenuse, okay. Adjacent, So we know that cosine of alpha, adjacent, which is the dir, right? So this is the dir, to hypotenuse, which is this entire thing. So what if we consider this righteous triangle, right? This righteous triangle. We know this, the length of this thing, this is literally nearest clipping plane. So this is the nearest clipping plane. And it's adjacent thing, divided by the length of this thing, which we can call B. So it's basically B, right? All right, so we can quite easily compute cosine, right? So because as you can see, you basically divided it, right? So we can maybe even erase it. So knowing all of that stuff, we can compute cosine of alpha. But we also know that cosine of alpha is this relationship. We know the NCP value. We know the NCP value. That means we can divide by NCP value, right? And that kind of get rid of that, and we have an inverse of B. But what's interesting is that I think it would be easier to just invert this thing, and you effectively end up with B over NCP, and you just multiply by NCP. So effectively, you do something like that. NCP, right? So, and that gets rid of that, and you end up with B, right? You end up with B, basically. So that's pretty cool. So when you can employ all of that stuff to find the length of this thing, as soon as you find the length of this thing, you know this point instantly. You know what I'm talking about? You know what I'm talking about? Like, you instantly know this point. You know the direction. You know the direction because the direction is basically that SP minus PP, normalize that. SP minus PP, normalize that, and then multiply by B, and you get exactly this value. And you can find B by just following this math a little bit in here. So does it make sense? Does it make sense? I think it makes sense. So yeah. And I suppose this is what matrix encodes. I feel like that's what matrix encodes. And finding this thing is also relatively easy, right? So we already kind of know how to do that. We already done that before. It's also kind of related to direction and whatnot. But yeah. So the more interesting thing would be, for example, when, what if this thing is completely outside of the field of view? How do you fucking render that? You have to take into account these kind of situations, right? You have to take into account these kind of situations. So yeah, when the angle between these two things is bigger than f of v and it's completely outside. But to be fair, maybe it is not that difficult to find. So the projection point effectively will be kind of outside of the range between P1 and P2, because what you're going to be doing, you're probably going to be doing inverse lerp, right? So your point is supposed to be between these two things, so you'll have to do inverse lerp, and that will be, you know, outside of this entire range. So so outside of field of view, you don't render, right? Yeah, you don't render. But to be fair, maybe a point somewhere is outside of a field of view, but then you see a little bit of it, a little bit of the sprite in here, so you kind of need to render part of it. So yeah, right now we can just like render everything, and if a stripe that we're trying to render on a screen appears outside of the screen, we just like don't render it, so it naturally like works out the way we want it to work out. So yeah, that's basically the math, my math, right? So not based on the matrices or anything like that, but I feel like the matrix kind of encodes that. So we can try to read the explanation. So they're saying that you need to, yeah, subtract the player position from the sprite. In our case, we actually do the opposite thing. Right, but anyway. So if anything, the experience showed me that it's better to rely on your own reasoning rather than the tutorial itself. It's better not to follow this specific tutorial like letter to letter. Just use it as an inspiration. Just get ideas from this tutorial and try to figure them out yourself. That is actually way better because you understand, you will understand each individual thing in here, right? So which will give you more control, right? But if you just follow this entire thing mindlessly, you may get somewhere, but you don't understand how this thing works. It's kind of useless because you can't control it. You can't control things that you don't understand. You can't modify them. And being able to modify things is very crucial for me, right? So because like, yeah, if you can modify it, I own it. So let's take a look at the subs. Some people subscribed, a lot of subs today actually. So, right, Fire Ion 95, thank you so much for Twitch Prime with the message trigonometry, Craigasm, trigonometry indeed. Trigonometry is actually kind of fun. I want to maybe, you know, refresh it because the last time I learned it a long time ago, right? So it's kind of embarrassing how little trigonometry I actually remember. Anonymous Gifter, thank you so much for tier 1. Thank you. For fuck's sake. People, don't make fun of an old man, okay? He's old and tired. He should probably be retired. But anyway, don't make fun of old men. So, any recent updates on trigonometry last few years? That's a good question. I don't know. I haven't looked into updates. Any math influencers can get me up to speed? Can read some articles for me so I know what's the latest hot stuff in trigonometry today? What we're gonna be doing? So we probably need to introduce the notion of a sprite, right? So maybe let's introduce some sort of an interface. Interface sprite. So what's gonna be the fucking sprite need? What's gonna be this fucking sprite? I suppose the sprite is gonna be something that I can have an access to pixel to. So I suppose it's supposed to have some sort of image data, right? So that's one thing I can say for sure. Image data. Okay, cool. Another thing Sprite has is probably position. So vector 2. So it does have position. Anything else? So another thing that Sprite is probably going to have is its height. Right, where exactly it is positioned, right? So, yeah, so right now it's going to be probably in mid-air, right? It's going to be in mid-air, but I think it should be in 3D space. It should be in 3D space, and there are some examples in here, like for example, this thing. Well, I mean, you can basically create a sprite that just has a space above it, so it appears just, you know, standing on the floor, right? It just appears standing on the floor. Let's put it back on the ground by, oh, okay. So, all right. So maybe they have some sort of a parameter for some of the sprites to sort of like them, to move them down or whatnot. Yeah, okay. So it would be interesting to actually read all that. So there's also transparency. So they're blending. Oh my God, look at that advanced shit. The alpha blending. What the fuck? What the fuck is this engine? What the fuck is this engine? Holy shit. Anyway. So, all right, we're gonna have some sprites in here. So I suppose let's just basically say sprites, and in here is gonna be just an array of a sprite, right? So this is an array of a sprite. Okay, and so if we take a look at the compilation arrows, it's a 1, 3, and yeah, so here we don't really have sprites. So let's actually initialize some sprites. Shall we? So here is the scene, here is the player. Maybe sprites should be part of the scene. I have a strange feeling that maybe sprites should be part of the scene, if you think about it. If you actually think about it. Right, so let me find interface scene. Yeah, so the walls, width and height. Could be, it doesn't really matter that much. Okay, so gonna be const sprites, and it's just an array of things. So sprites is implicit any, so let's actually say that it's going to be a sprite, which is a game sprite, and maybe, yeah, I already no, I didn't export it, interface sprite. Let's export this entire thing so it's visible in here, and 48, game sprite, cannot find namespace game, really? You can't just do it like that in an array? That is bizarre, even though, like, here's the namespace. Are you trying to tell me that I actually have to do something like, you know, type sprite and then just use sprite in here? Is that what you're trying to tell me? Cannot find namespace game. Am I going fucking crazy, mate? I feel like I'm going fucking crazy, but anyway, maybe I just have to do something like this. All right. So, and in terms of image data, let's say that this is going to be TypeScript, right? So this is a TypeScript image data type of game. Yeah, probably have to do something like type of game or whatever. So image data TypeScript, and position is going to be I don't know, maybe new vector 00. Something like that. Is it going to be working? Is it going to be working? Cannot find. Okay, so this has to be a game. Are you happy now? Come on. It's not a file to provide a sprite. Image data. Oh. So TypeScript is apparently either image data or RGBA. This is so... Oh, okay, I see why. Okay, I see why. Okay, so let's get rid of this catch, right? So essentially what I'm doing in here, if I can't load this entire thing, I just use RGBA instead of it. So because of that, it's either image data or RGBA. But right now it's kind of breaking this entire thing, so I think I'm gonna just remove that. And now it compiles. Okay, so that would compile. Goddamn TypeScript, bruv, goddamn TypeScript. I want to have like an interesting sprite somewhere. Just like you know, small little blip thing that I could use for different stuff. So let me actually maybe go to the open game art. So okay, effect a spark sprite. Yeah. No, I want to have some sort of a spark. So there's sparks. Okay, so there's a fire. So this is that the entirety of it? Oh, okay. All right, so this is actually GIF. This looks cool. I like that. All right, so let's download this entire thing and take a look at what we have in here. So assets, images. We already have a folder for open game art. Right, so I'm gonna put this thing and I'm gonna download this stuff in here. It's taking some time, but to be fair, I should actually get this thing. So this is the original URL, right? So this is the original URL, and this is the name of the archive that we have in here. So let me see what's inside of it. Okay, so sparks, and let's open this stuff. Let's move it in here. I'm gonna open this kind of thing. Blend, dude, what the fuck is the? Why is that the blender? Oh, how would you on earth would you guess that this is? It's really, this is not what I need. I need 2D. All right, so I don't know, like a fire, like magic effect, 3D. This is what I want. I should have actually done that earlier, right? So that's what I want. This kind of things. Yeah, that's pretty cool. So there's a water effect. Water. So let's take a look at that. Water magic effect, and let's just download this thing. Save that, and wget this thing. Boom. Water effect. Okay, so what do we have in here? Goddamn Windows users, create the root folder. SMH my age. SMH my age, brother. SMH my age. Okay. So what do we have? Water. Yo, they are basically like a self-contained things. Bruv. This is so goddamn cool. This is such a cool effect. Okay, so water. Water. Ooh, man, I love this shit. Alright, so water 4 looks cool. So what else? Like 03? Ooh. Ooh. Damn, bruv, damn. Imagine shooting this shit. Like shooting all that. Damn. Alright. So credits. Okay, I saved all of that, and it's more like, what's the name of the archive? What's the name? Water effect. So it's a water effect zip. Alright, cool. Water bending, E05. What is 05? This one is kind of, ooh, it's like it's a React. Look at that. This is React. It's kind of weird React, but I mean. Anyways, so let's go ahead into the index.ts and maybe load this as. So what we're gonna do is just load image data, assets, images, open game art, and what is it fucking called? What? Yeah, so it's a 05, 05, this thing. There we go. And we're gonna just call it water. Right. And in terms of sprites, it's gonna be just a water. So the position could be somewhere maybe at the player's position, but I'm not 100% sure. So here we kind of have this sort of thing. So if I remove this column, we're gonna have an interesting situation. So essentially we have 4 pillars, 4 walls in here. I want to place the sprite somewhere here. The size of the cell is 1 by 1, like this. And if I wanted to place in the center of this thing, I think it's a 1.5 and 1.5, roughly 1.5 and 1.5, like this. So that's a pretty good position, I think. That's a pretty good position. So, okay. There's no compilation errors, there's nothing, and everything looks Gucci, everything looks Tamaguchi. Okay, let's go into the game TS. So here we have the sprites, and one of the things we probably have to do, we have to introduce a function that renders the sprites, right? To render sprites, it accepts the display, right? So it accepts the single display, and it probably just accepts the sprites, nothing particularly special, right? So it's going to be a sprite. Cool. And it is supposed to be called, according to the recipe in here, right? So in the article, it's supposed to be called after we're done with floors, ceilings, walls, and so on and so forth, right? Render sprites. Display sprites. So here are sprites. Okay. So we're going to be iterating them. So you're supposed to sort the sprites. I don't really want to be sorting them right now, right? I'm more concerned with actually putting them on the screen because we have only one sprite, so we don't have to be concerned with all of that, right? So it doesn't really matter that much. So I'm going to put it to do z-sort the sprites, z-sort the sprites. And what we're going to do is just going to look through the sprites. Can I do something like const sprite of sprites? Is that a good thing to do? Is that how we do that? I think that's how we do that. So yeah, now we get a very interesting thing. Since we're rendering, we're projecting all of that stuff. We need to know the position of the camera, direction, and stuff like that. So we also need to get the player. So this is the player. So render sprites. Here we're supposed to pass the player in here too. So the player is rather important. Can you show the in-game progress? I don't know if the game is actually working right now. It is not working right now, but we can open the deployed thing. Raycasting. So that's the current state of the engine, right? So you can actually play with it yourself if you're interested. So WASD to control and stuff like that. So it's rendered using like a retro 3D techniques, and it uses 2D canvas, not 3D canvas. It doesn't use any OpenGL or any headway acceleration or anything like that. So that's basically the progress so far. We're just like rendering the sprites. Hopefully we'll succeed on that. Okay, where's the math? Where's the math? So SP minus PP. SP minus PP. So I suppose what we have to do, we have to take the sprite position, and I feel like we'll need to clone it, right? So because the actual vector in here, I feel like it's supposed to be reused, though we can maybe have, like, we can pre-allocate one of the vector in here, right? So how are we gonna call this specific thing? How are we gonna call this specific vector? So it's more like a SP, right? So let's actually call it SP. So I have to provide 0, 0. I saw in 3JS actually very cool ideas that just like basically initialize it with 0. So that way, if you just create this thing, it's like already initialized. So one of the things we can do with SP. So first thing we do, we copy the sprite position, right? So, and copying basically just assigns. Oh, I don't have a copy. Okay, so yeah, so let's actually implement it. I thought I had it. So it's supposed to take the other vector, right, and it obviously returns this, and just sets that to this and returns this, right? Returns this. All right, so we copy the sprite position, and then we subtract the player position. We subtract the player position, and we get this specific vector, right? So we get this specific vector. So, and the reason why I don't want to clone this is because, like, if I just create this one vector once, it's not going to be created for each individual sprite, right? So it's going to be reused for each individual sprite. So we sort of like pre-allocating a bunch of objects and just use them. And thus we're reducing, you know, the pollution of the garbage collector and stuff. All right, so we subtracted this entire thing. So we also need to have the direction. And honestly, the direction vector is basically the same for all of them. Right, so we can call it dir. And essentially what we can do vector angle. And this is just a player direction. So there we go. So we have a sp and we have dir. We have a sp and we have dir. And now we just have to do dot product, right? So we just do the dot product. Funnily enough, dot product is just a number, so that means there's no vector creations anywhere, so which is good. So I just do sp dot dir, right? So sp dot dir. And after that, I have to divide it by the length of this entire vector, right? So I divide it by sp length. So, and that gives me the cosine of alpha between those things, right? So it gives me that. And that means I have to take this entire value and divide it by the near clipping plane, right? So divide it by the near clipping plane. So yeah, I guess that's basically it. And that gives me the length, right? So that gives me the length from the position of the player, to this point on the screen, right? So that's pretty cool. So how can I call this entire thing? I can probably call it like a distance. Right. Maybe just d. Dist. So, and what that means, I can now take sp, right? I'm taking sp, and I'm kind of like normalizing it, right? So as far as I know, normalizing also in place, right? I normalize this entire thing, but then I scale it by the dist, right? I scale it by the dist, and that thing basically becomes the point on this sort of like plane, the point on this plane. Now I need to make an inverse lerp between P1 and P2. So, and to do P1 and P2, I need to have them, right? So to get the P1 and P2, I have to do FOV range, right? So this is a player FOV range. And I can do it only once, right? So these P1 and P2 wings of FOV are going to be reused on each individual sprite, hopefully. So that SP is basically already projected. It's already projected, and we can, yeah, we just need to do inverse lerp. How do you do inverse lerp, by the way? So a regular lerp, it allows you to take P1, P2, and T, which is a normalized value from 0 to 1, and it will get you the value between P1 and P2. An inverse lerp, actually, like ilerp, it takes P1, P2, and SP, and returns you T, which is a value from 0 to 1. Right. I suppose the way you do that is just like you take P1 minus P2 minus P1, and you divide it by P2 minus SP. Right. That's what you do. So, and that way you get the T. So, but that's more like a distance between them, right? So that means we have to do P2 distance to P1 divided by P2 distance to SP. And none of that creates any of the new values, right? It doesn't create any of the new values, so that means you can just do that, right? The distance 2 is just a security of square distance, and square distance doesn't create any of the new vectors, right? So that's totally fine, and that's basically the T, right? And it's a value from 0 to 1, which indicates how close you are to all of these things, right? So how close you are to all of that. So do we have any division in here? So SP length, can it be equal to 0? It probably can be equal to 0. Can any of that stuff be? Okay, so if the dot product here is equal to 0, you kind of end up with this thing being equal to 0, and that's the division by 0. So, and I wonder if this is something that we want to be aware of. Maybe we want to be aware of that. So we can maybe move that to dot. All right, so this is going to be dot. And if dot not equal to 0, only then we do all of that. Otherwise, we skip this entire sort of iteration, right? I think it makes sense, right? I think it makes sense. So afterwards, yeah, we have this T, and that T is rather easy, right? So it's essentially the X coordinate. It's essentially the X coordinate. So you can try to do the following thing. You take the distance, display, I mean, image data into actually back image data into which you're rendering everything, and you take a width and you just multiply it by T. And you get the X coordinate of the column where the sprite is located. That's it. That's actually it, right? Theoretically. Theoretically, that's basically it. So, and we can even try to render something there. I think that's going to be rather interesting. Right, so, but we want to kind of skip the situations when T is outside of the range from 0 to 1 or whatever. All right, so less or equal, and the T is less than or equal to 1, right? So we can try to do that. So, and for now, what I'm thinking is that we probably want to, don't want to really render the sprite yet. I want to just render a spot where the sprite is supposed to be located. That's what I want to do. How are we going to be doing all that? how can we do all that? So I think I'm going to be drawing on the CTX, which is the actual visible canvas, which allows me to just use the context, like canvas context primitives, right? So it allows me to do that. But at the same time, what do I want to do? I probably want to do the scaling situation. Do I want to do the scaling situation? That's also a good question. So I can do display CTX, save the current state of the context, then restore the context. So the audio is lower. Maybe I'm just like far away from the mic. So is that better? Is that better? Okay. So if the audio is too low, just let me know. I'll be closer to the mic. Okay, cool. So it's maybe I should bring it a little bit, but I'm a little bit worried that it's gonna fall from the desk. That happened once actually, and it's not pleasant. So let me maybe feel erect. So essentially, what's going to be the x? All right, so the x is going to be display CTX canvas width multiplied by t. So that's basically the x. Y is probably going to be a half of the height. Right, so I think that's fine. I think that's fine. So this is where we want to render something, right? So let's go ahead and do that. So display CTX. So maybe we want to even do something like fill style, and let's fill the style with red so it's instantly visible. And let's do that for the entirety of the thing. And then I'm going to do display CTX fill rectangle. So in terms of coordinates in here, what do we have? So x and y, w and h. All right, so I would say it's x minus the size. So what's going to be the size? So const mark size, let's say 100. So it's a minus mark size half of the mark, y minus mark size half of this thing, and width and height is a mark size. So this is going to be like a rectangle. All right, so all of that seems to be compiling. And that's basically how we figure out the projection of the sprite on the screen, right? This is my take on that. I'm not 100% sure if that's the correct way to do that. So SP, if it's too close, it's a, yeah, so we have to also be super careful if SP is equal to 0. Or maybe we have to, so if it's negative, by the way, if the distance negative, that means it's behind us. So that means we for sure don't want to do anything about that. So maybe it makes sense to actually pre-compute that. So let's say SPL, this is going to be SP length, right? So this is SPL. And we're going to say that SPL is greater than 0, right? So if it's less or equal than 0, let's actually do continue. Continue, right? So then we do the dot product. And the dot product also means something, right? So, but I suppose we can just do something like this. So I suppose for a dot product being like something incorrect, SPL has to be less or equal than 0. So I think it's fine. I think it's totally fine. So what I'm doing here, I'm just guarding from like a bad values, from potential bad values that may ruin something. And I think it makes sense, right? So let's just continue, right? Then it's going to be that, then we do that. So this thing is very unlikely. Well, it could be 0, actually. Distance. So distance to that. Honestly, I think it's more like distance to P1, but I mean, there could be something wrong in here as well. Distance of 2. Wait a second, just a second. So SP P1 to, yeah, I think it would be better to actually do P1 to P2 and then P1 to SP, yeah. P1 to SP, that makes a little bit more sense. If it's too much equal. If they're equal to each other, this is probably going to be... yeah, okay, I figured that out. So if it's equal to 0, and it can be equal to 0, this entire thing is 0. Oh, okay. I figured everything out. Everything's fine. All right, I guess that's the thing we want to do. Yeah, so they were inversed. Yeah, they were just inversed. I think that's the thing we want to do. So we just figured out the position of the thing. It's only the position, so we're not rendering the sprites yet. But we're gonna get there. All right, so nothing is rendered completely, even though everything seems to be compiling. So there's some sort of error. So let's take a look at the console log. All right, so resources not found. Okay, so water was not found. Understandable. Let's take a look. Where's the water image? So this is not open game art? Oh, it's probably additional prefix in there. So water effect. All right, so let's add water effect in here. All right. So I can't see shit. Yay! I can't see Scheiße, even if I scroll around. That is very poggers. Okay, so let's take a look if we have any errors. Okay, so everything's fine, right? So it's just like not displayed at all. It's simply not displayed. Interesting. I know why. I literally know why. Because so we're just collecting all of the pixels from floor, ceiling, and walls, and then we need to put them onto the main screen. But then I rendered the sprite into the main screen before I swapped this entire thing. Okay, so I just do that in not correct order. So that's basically what happened in here. Right, so hot reloaded the module. Right, so that seems to be fine. Still, no, don't see anything. All right, that's very bizarre, I would even say. That is very bizarre. Even though, all right, so let's do the following thing. Console log X and Y and just throw stop. Where should it be rendered? Between the pillars. So let's give it a try. So I'm gonna open the DevTools. Can you see shit? Let's hot reload. Oof, that is interesting. So we never get into that point. So it's supposed to crash, but apparently we never get here. It's never between 0 and 1, like at all. That is fascinating. Is that because we don't have any sprites? So because... yeah, okay. So let me see. So maybe I can print SP and just throw. Where is that? Okay, so that broke. I'm really happy to see that. What does it say? Okay, so this is a vector 2 and -2. This is very interesting. Okay, so that's fair. That is actually fair. So let's print SPL. Let's print SPL. Okay, so SPL seems fine. Let's print dot. Dot is 1, so that seems fine. So the distance that we print in here is 0, 1, right? It is 0, 1. So then we take the SP, which is basically the direction. We normalize it and just scale it by the distance, so it has to be SP. So this is the value. So it's sort of like negative. Right, it's sort of like negative, and then if we take a look at T, right, if we take a look at T, that T is like completely blown off the charts. It's completely blown off the charts, and I don't really, maybe it should be visible at least somewhere. That's the thing. It should be visible at least somewhere. So if I take a look at the sprite position, If you take a look at the sprite position is half, okay. And the player's position is, yeah, 4. So it should be visible to some extent. Direction, player direction, we just use that, so everything's fine. I really don't see any problems. So maybe I just need to make a small break, right, to think about what I've done and maybe refill my water and stuff like that. And yeah, so let's make a small break, and after the break we're gonna figure out what exactly is going on here. All right, so let's actually try to visualize this entire stuff on a minimap, right? So on the minimap we can at least see the reality on the top, right? So first of all, let me open the game. Right now minimap doesn't display anything at all. So we have throw in here, so let's don't throw anything, and render sprites, let's don't render sprites. Something like this, so let's refresh this entire thing. Yeah, so minimap does not display shit, so we need to at least fix that. So let me quickly do that. So for now, I suppose I'm gonna just quickly fix image data. So style, let's say that we're gonna render all of these things with blue. Right. So yeah, there we go. So now we can see the walls at least on the minimap. So the problem with the minimap is that it's kind of small. Right, so let me make it a little bit bigger. So display cell, what if I make it like 5? Yeah, that's a bit better. So maybe 7 even. Okay, cool. So now, in the minimap, I think I want to have sprites. Right, so we're gonna have an array of sprites. Just a single sprite. And when I render the minimap, sprites, do we have any problems in here? Everything seems to be fine. All right, and afterwards, I want to just render the sprites somewhere. So let me see. So we just render some of that stuff. This is strokes and everything. For let sprite of sprites. We have the position of the sprite, so we have to do context fill rect, and it's basically sprite position x minus. So we have a player size, a notion of a player size, and player size is rather small. So maybe we're gonna just use sprite size. So where's a player size is defined? Okay, so sprite size, which is gonna be maybe 3. And I'm gonna just copy paste this entire thing to here. This is, yeah, I can query replace player with sprite. Boom, easy peasy lemon squeezy. Yeah, there we go. So, and honestly, I want to do ctx fill style, and it's going to be red. The color of the sprite is going to be red, as you can see. So everything is red. So the problem here is that I can't see the FOV because the nearest clipping plane is too far away. It's like you know, 1/10 of 1, right? So let's maybe make it 2 or something, right? So now it is more visible, but it creates a very funny effect. So you see, like nearest clipping plane, it just like really clips that thing. If maybe I can get rid of the main minimap when I render the minimap. But maybe, I mean, I can just like not render it at all, or maybe make it super small, right? 2. Let's make it super small. Yeah, so you can clearly see how the clipping plane actually clips the walls. That's why the near clipping plane distance is so small, right? So it doesn't do this kind of shit. So it's actually kind of funny. I really like that. But I need to do that to be able to see that FOV. All right. So, and as you can see, this is where the sprite should be. This is where it should be, but we can't see anything in here at all. Like, at all. So that's the problem here. It's kind of cool that it's like on the angle. Yeah. It also cuts everything. I really like that. It's super fun. Anyway, so let's make it something like 7 again, so we can see the entirety of the minimap. This specific minimap is a very useful, like a debug tool and stuff. It's a very useful debug tool. So here we have like a line width, which I think we should make a little bit smaller. Right, so it's a little bit finer. We can finally see what the fuck is going on in here. So I'm super happy with that, at least. All right, so let's actually start porting some of this stuff in here. So sprite, render sprites, right? So that's what it was, render sprites. And in here, we have a sp, right? So we have a sp and we have a direction of the player. So yeah. So we already have P1 and P2 and so on and so forth. Okay. This is the place where we do all of this thing. And honestly, I suppose once I figured out this thing, I can just, yeah. So I'm just thinking how I'm gonna be, you know, doing all of that stuff. Right, so I have the distance and I have the dot product which divides by that thing. Right, and that dot product. So by the way, did I figure out correctly the definition of the dot product? Maybe this is where I made a mistake. Yeah. Maybe this is where I made a mistake, so let's quickly do that. I want to see the definition with the cosine. Where's the definition? Okay. All right, so I was correct. Right, so I was actually correct. So it's just both of these things. All right. So the direction is 1, because of that we don't have to divide this entire thing. So the problem is so this factor is not particularly useful. I can't, like, I'm trying to think what can I can visualize in here. I don't see what I can visualize in here. I just found the direction. One of the things I can do to visualize this entire thing is maybe take the player position and just like add, like obviously I need to clone it, right? So because it's going to modify it, add sp, and that gives me the point that I could visualize, right? So I can maybe stroke a line from one place to another one. Right, so I can provide the CTX, I can provide the player position, and then I can provide this entire thing. Right, it's kind of like redundant, but it's just like I'm doing that to check the math, right? So I'm just doing that to check the math. Okay, so that makes sense as we move around. That creates everything I want to see. So, and another thing I can render in here is just a position plus the direction in here. So, and also CTX stroke style, let's actually say it's yellow. Right, so let's actually do that in yellow. And it did that. Okay, so it kind of worked, right? So okay, so we can see all of these things. This is actually kind of cool. Right, like that. Yo, what the fuck? So that's so cool. All right. So to be fair, we can maybe stroke this entire thing once, right? So because it's going to be a single direction for each sprite. Right, okay, I like that. Render sprites. Finally, I found something that I can kind of visualize. So after that, I want to check that SPL length is correct, right? If it's less or equal than 0, that means something is weird in there. Though, like it doesn't, it's probably never going to be actually less than or equal than 0, right? So it doesn't make any sense. But, I mean, it could be equal to 0, if you know what I mean. So let's put it this way, not equal to 0. And this one is also not equal to 0. All right, so after that, we got the dot product of these things, and we also divide it by SPL. So we also divide it by SPL, and then we get the distance. All right. So afterwards, we're just normalizing this entire thing. And this is what I would like to maybe try to render one more time. All right. So, and I think I found a mistake. Because it has to be relative to the position. Okay, so player position, then add SP, because it's only a direction. Yeah. It's only a direction. Did I forget to save? I think I forgot to save. Damn, I didn't see shit. Alright, so that didn't... Yeah, that explains it. So what we have to do in here is just take this point and maybe mark it somehow. Right, so we have to mark it somehow. So this is a projected. So const projected. And here we are going to do this kind of thing. So replace projected. Got it. Look at that. So it works correctly. And I think this is the bug. This is the bug that I was talking about, because the actual point, right, the actual point has to be player position plus. So the thing you have to do, you have to scale it and then add player position to that, and that's your SP. Right. I said player. The fuck is going on? Emacs, don't be so slow. Alright. Is everything okay? I think it hot reloaded everything, yeah. That is basically what we should have done. To make this entire thing visible. Yo, that is so cool. By the way, we can continue sort of porting this entire thing. Render sprites. So if we add this check, right, so we can say if kind of not continue. So we can add this thing. All right. Yeah. As you can see, if we all right, this one is bizarre. So it became like a negative, but it still was trying to render some shit, so... I would expect this thing to become negative, but I mean... Maybe we can do something like absolute. Math absolute value is less than that. Nah, it's still going there. Well, I guess that's fine. So I found the error. That's what's important. We found the error. So which means that let's reduce the size of the minimap where we set the size. I don't see the size. So it's a minimap size in here. So it's basically 3. Let's actually reduce it to 3. So we don't care about that stuff anymore. And now I can render the sprites. And in here, what I have to do is, after we normalize this entire thing, I have to add the player position like so. And only then this thing makes sense. All right, we'll go. There we go, we have a sprite. So, and we can see it from the other side. So it would be nice to maybe do near clipping plane back to its original value. Right, so it doesn't clip. Yeah, so here's the sprite. Like you can see through that and stuff like that, so it's a usual thing. Right? So it's totally fine. it is a totally fine, my friend. So it is kind of bizarre in some sense, but the algorithm is there. It's pretty cool. It's pretty cool. It's pretty cool. So now, based on the distances and stuff like that, you can figure out, you know, the size of the sprite itself, right? So, yeah, so it's pretty cool. Size seems inverted. Size is not taken, is not computed at all, right? It's literally hard coded. It's like we haven't got to that point yet. So, but we'll get there at some point. That's pretty cool. So there's something that kind of bothers me with random minimap when you look at the minimap. So minimap size, it's, let's actually go back in here, right, back to the minimap. Where am I, by the way? Let me see, shit, let me refresh. Okay, so yeah. So let's get rid of the render sprites. We don't render the sprites. Near clip and plane, let's put it back to 2. Yeah. So when we have this kind of situation, it should not be rendered. And when we have this kind of situation, it should be not rendered either. So we need to somehow protect ourselves from these kind of situations. And so as you can see here, it is rendered as well. So this is the really strange situation. How can we protect ourselves from DOS? It only seems inverted because everything else... Yeah, so the size stays the same. So the size doesn't change at all. Did you change HMR to your own implementation? What do you mean change? I implemented it myself from scratch. I watched what yesterday, but I stopped in the middle of it. I didn't change to my own implementation. I implemented it myself day one, full stop. Because why the fuck would you do anything else while working in a toy scripting language that is dynamic? That's the definition of dynamic language. Anyways, what do we have? Let me see. So this is a render minimap. Render minimap. Like, language literally has eval. And people think they need a fucking, like, an entire framework to hot reload anything. Like, that's beyond me. That is literally beyond me. Like, your language literally has eval. What the fuck are you talking about? Are you okay? Anyways, what is going on here? So we have this kind of thing. So SPL length is always going to be actually positive, like it doesn't matter. Length is always going to be positive. So we need to kind of look at the dot product, right? So the dot product kind of gives you the information where you are, like information about how big your angle is, right? So because it's a cosine of an angle, right? It's a cosine of the angle. And to be fair, I don't really have an intuition about the cosine of the angle, right? I don't really have that good of an intuition. So yeah, I can try to do some things like this, right? So if t is 0 equal t and t is less or equal than 1, if not, right, if not, you just, you know, continue. So that should kind of protect you from some of the situations, right? So it doesn't protect from left side. That's what worries me. It protects you from right side, like this, but doesn't protect you from this one, and it like makes me question, like, what the fuck is going on there? Like, what the fuck is really going on there? So maybe we could print a text, draw, how do you draw text? So we can maybe set, let me try to do that. So this is going to be more like 32 pixels, white, and the text that we can put in here is going to be t. We can put it at SPX, SPY. Right, SPX, SPY. I can't see shit, bro. Why don't you render anything? Did it crash? Don't tell me it's crashed. Display is not defined. Ah, I see. It's fine. Display is not defined. All right. So what I have? Oh, Jesus fucking crap! This is the okay. Okay. So 1 pixel. Can I just have 1 pixel? Okay. Oof. It's actually growing in here somehow. How the fuck does it grow? Ah, because it's a fucking distance. God fucking damn it. Okay. Because it's a fucking distance. So we don't really want to be doing the distance. We don't really want to be doing the distance. We want to be doing something else actually. But the question is, what exactly we want to be doing? Maybe only on the level of like X. But nah, distance is what we want to be doing. Distance is what we want to be doing. So yeah, I don't really know how to protect that. Maybe I'm gonna do that a little bit later. So okay, I guess we figured everything out. I guess we figured everything out, and maybe I'm going to simply disable this entire thing for now, because like being able to render these things is kind of useful, so I don't really want to get rid of that. So rendering the sprite projection, maybe dot product. Yeah, I was thinking about that, but I already said that I don't have an intuition about dot product, right? So I already explicitly said that it would be correct thing to do dot product and do something based on the dot product, but I don't have an intuition about dot product, so I'm not gonna do that. All right, so I know that dot product has some sort of a meaning about the angle, and people do use it. Dot product equal to 0 means something, right? So I think it means 90 degrees or something like that. So if you take a look, since it's a cosine, the cosine is equal to 0 when it's 90 degrees, right? Well, okay, so we can do that. So I suppose then it goes to negative part, right? Then it goes to negative part. So it goes to negative part, and then it goes backwards, right? So then it goes backwards. We can try to, yeah, one of the things we can do, we can just, we can simply forbid negative values. That's one thing we can do. All right. So because it's basically cosine, right? Here it's positive, then it goes towards 0, right? It goes towards 0 at 90 degrees, then at towards 180 degrees, it stays in a negative. Okay, then it essentially stays in a negative while going to 270, right? So I think it's 270, yes, 270. And then it starts going here. So it's not particularly like a useful thing for us. It's not particularly useful thing for us. But what if it goes like... We can do something about FOV, honestly. Right, we can do something about FOV. So essentially, where is the dot product? So what is value of cosine at 45? We can basically pre-compute the cosine at 45 degrees at half of the FOV. And we can just use that as a value to sort of make sure that this thing stays within the right stuff. Right, so that's one of the things we can try to do, but also we have to multiply by the length, width, and whatnot. Well, we actually have an actual FOV, so that's totally fine. So render minimap, where is that thing? So let's enable that. Okay, so thank you whoever asked about like dot product. You forced me to actually develop an intuition. It's actually really funny, like I didn't have intuition, now I have a little bit of intuition, which is good. Right, so essentially here, what I want to do. So I want this thing to be from basically math cosine of FOV, half of the FOV, right? So half of the FOV. So it has to be less or equal, because I know for a fact that this is literally a cosine, right? Because we even divided it by SPL, so it's literally cosine. So n dot is less or equal than 1. So that's what we're trying to do in here. So, I mean, this kind of operation is probably slow, but I mean, it's fine for now, this, and it doesn't fucking work. It's something broke. Something fucking broke, bruv. Something fucking broke, bruv. So, oh, fucking C brain damage, I swear to God. This fucking C brain damage. Anyway. Alright. And it's shit, by the way. It's fucking shit, meat. It's fucking shit. So that means my intuition is not particularly correct. What if I have a half of a pixel? So wait, not. Now we're fucking talking, motherfucker. Now we're fucking talking, and it. Holy shit! I just developed an intuition for fucking dot product. What the fuck? I thought I would never do that. But I just like achievement, like I understand. But because it's basically cosine, right? So that's it. Like there's nothing much to say in here, right? It's basically cosine, but yeah. It's fucking easy peasy, lemon fucking squeezy, motherfucker. Fucking easy. Fucking easy. Anyways, so let me see. We can pre-compute this thing. By the way, we can pre-compute this thing. Who said we can't do that? Right. So we can always say half cos of half FOV. Yeah. I guess it makes sense. Since it's a constant, cos of half FOV, we can even do it like that. So we don't recompute it, cos of half FOV. Yep. So only compute it once. All right. So that's the only sort of like check that we need here. Render sprites. So n is going to be replaced by this check, which is somewhere here, and we don't need this check anymore, right? If it's equal to 0, that's it. We're not going to render anything. All right, render sprites, enable this shit. Maybe don't render minimap. Yeah. Pretty cool. It's pretty cool. I really like that. So that single math call, cosine is pretty actually heavy as far as I know. Thank you, anonymous gifter. Thank you for gifting subs and shit. Subs and shit. Something really weird happened. I forgot how to pop the previous mark, but yeah, whatever. So let's put 0 in here. Okay, so everything's pretty cool. I can safely disable the minimap or just like, you know, reduce the size of this thing. And I can bring back the near clipping plane like so, right? So everything still works. Everything still works. Nice. Nice. So we need to implement the rest of the stuff. So we need to now figure out the size of the sprite based on the perpendicular distance. Render sprite. So perpendicular distance. So we know the location of the If we take a look at how we render the walls, render walls. So we have this z buffer. So this is a perpendicular distance. We take this is what we do. We take a vector, which is like you know, vector from the player to the thing, and we do a dot product with the direction. So essentially, let's get rid of that. Though we might need x and y. At least we might need x on the screen, right? So x is kind of useful, and y is going to be just slightly different. So we take the sprite position, right? So this is a sprite position. We're probably going to clone it, but then we're going to subtract the player position, right? We're going to subtract the player position. And then we want to take a dot product with the direction. We do have a direction up there, yeah, so that seems to be good. And that's basically essentially like vector. Yeah, so that's the perpendicular distance. P dist. Yeah, perpendicular distance. So you have this sort of distance, you have this sort of distance, but this is a perpendicular distance. That's pretty cool. And that's the one we have to use to figure out the size. And size is essentially going to be sprite size, the distance divided by the thing. So there was something, where is the render wall? Render walls, stripe, yeah, so we take the back image height, the full height, and divide it by that. Right. So, but do we have, yeah, so we have a display. So this is a sprite. Okay, that's very cool. That is very cool. That is very cool. But if we're going to be drawing that on the on the screen. Ice Leo, thank you so much for 5 gifted subs. Thank you. All right, so this is basically the sprite size. Right, if we're going to consider the sprite size is equal to 1, right? So that's what we're going to be using. But we can always maybe like take half of that, but yeah, whatever. So let's actually do CTX canvas height. Right, so this is going to be CTX canvas height. And essentially, what I want to do, I want to render this entire thing like so. So this is going to be sprite, sprite size, and also this is sprite size. I feel like that's it, basically. In terms of y, const y display ctx canvas height half. That's gonna be that, and it's just gonna, yeah, that's the thing we need to do in here. That's the thing we need to do. Go. So it's rotating. Yeah, so okay. Pretty cool. So I understand the math. The fact that I can just like modify things and it works means I understand math. And that is so fucking important. That is insanely important. One of the things we can do in here, right, so we can take a half of that. Yeah, now it is like that. Yeah, that's cool. That's very cool. All right. So, and the last thing that we need to do in here is the Z buffer. So we're not rendering directly into the back image, right? So into the back image, we drawing it like sort of like overlay similar to minimap. We have sort of two canvases: the canvas for array casting, which operates on a level of single pixels, and the canvas with overlay where we can use the actual things, the actual canvas and stuff. So this is an overlay stuff. It's not within the pixels or anything like that, right? So one thing we need to do is make it render within the pixelated canvas with a like lower resolution and stuff like that. So that's one thing we have to do. How are we going to be doing all of that? All right, so we have to get rid of the display, right, of CTX, and we have to start working on back image data, right? So we're rendering into the back image data. So the other CTX, this is back image data, and this is also, well, I mean, this one is going to be rather interesting, right? This one is going to be rather interesting. So we now have to sort of like do another loop that iterates from left to right. So yes, we need to do the stripes. We need to do the stripes. And yeah, what's funny is that like X, so you can do Y, which is half of this thing. So what if I put 75 in here? Just let me bring back CTX, because I think I can figure out something cool. So this is the full. Fuck. Okay, so everything's fine. So this is the full. I can reduce its size with this factor, and I feel like I can now lower it down with this factor. Kind of. Nah, doesn't really work that well. No. Or maybe I actually just did too much. What if I put 25 in here? Yeah, I think it's too much, right? So it doesn't really fit perfectly. Right, so it's more like a half. Yeah. I'm not really sure how exactly to offset that. I'm not really sure how exactly. But to be fair, once you kind of figure out the full size, essentially, what you have to do, you have to project a full square. Just project the full square on the screen, and that's it. If you want to now sort of reposition your sprite within the full square, just render it like this, and it will appear on the floor, right? So just project a bigger one that encompasses the entirety of the boundary, right? And then if you want to put it on the floor, just like put it in here. So I think that's the way to go in here. So that's the way to go, without modifying too much of the projection code and everything. So I think that makes sense. I think that in fact makes sense. So that means I'll just need to update some of that stuff in here. Yeah, the math will be simpler. Yeah, I also think so. Anyways, so let's go and just do pixel by pixel stuff. All right, so this is going to be back image data. So this is the back image data. So CTX, and this is back image data. So and in here, instead of doing that, what we have to do, I'm thinking that I also need to do the floor for these things. So I'm dealing with integers. So X and Y are now integers. So and now, so this is the this is the sprite size. I also feel like I need to do this floor. So here we just do cloning, so sub, and so on and so forth. All right. So the sprite size. In all fairness, I'm really not sure. For now, commit, push time. It's not finished yet, though. It's not finished. So we need to have an iterator. So let me iterate from X. And I want to iterate from X, so I need to call it an iterator. So this thing is going to be sort of like a center, so it's going to be CX and CY. So X is CX minus half of the sprite, right? So it's going to be half of the sprite, and I'm going to just take a floor of this entire stuff, right? And then this one is going to be basically plus math floor plus. We might as well factor them out into x1 and x2, something like x1, right? So we don't recompute them over and over again. So x1, and this one is going to be x2. X2, something like that. So yeah, that's what we're iterating in here. X1 and X2. CY is probably going to stay the same effectively. Yeah, it's going to stay the same. All right. So now what I want to do, I want to take display back image data. So I'm going to be using Y. All right. So I'm going to be using Y multiplied by the back image data width. So, and it's more like, yeah, so this has to be also X, but it only makes sense if X is within width and height. So one of the things we can do here, by the way, we can do it like let, and if X, we can clamp this entire thing. Can I just clamp? Math clamp. Is there something like clamp? Nah, there's no such thing as clamp, but I want to clamp a certain value from 0 to the back image width minus 1. Max then min, probably, but I mean, it's just like, it's not particularly convenient for me, unfortunately. So this one has to be plus, by the way, but I mean, I can copy paste this thing and then just do plus. So that's going to be const. All right, that's cool. So this could be essentially index, right? So it's going to be const index. We compute it sort of once. And then in here, I can do plus 0 equal to 155. 1 is going to be 0. 2 is going to be 0. Something like this. So we have the actual distance in here, right? So what do we use it for the stuff and everything. And we want to also do a z buffer, right? So essentially what we can say, if the perpendicular distance is smaller than the display z buffer x, only then we're rendering this entire thing. So now we're like properly you know, overlapping with walls and stuff like that, in theory, right? So maybe I actually fucked up something there, but I don't really know. So we don't have to do that stuff anymore. We don't have to do any of that stuff. Display CTX, right? So within the render sprites, we don't have any of these things. Okay, so that should be kind of enough, I think. So, and it crashed. Okay, so let's take a look at the error. So should also update the end, not really. A clamp, oh, okay, so clamp, I forgot about the clamp, god damn. All right, function clamp. So it's a value, min and max. Right, so in here we can just do, I don't know, if this thing is less than min, return min. If it's greater than max, return max, otherwise return value. Why is it highlighting it so this weirdly? But I mean, whatever. Y is not defined. 569. Because it's called CY. All right, I can't see the sprite though, but fuck. All right, that was interesting. So image data, so that means we did something incorrectly in here. So what if I remove this thing? All right, so it's not displayed correctly at all. It's not displayed correctly at all. So I wonder why. So CX sprite X, but I mean, wait, we have to do like a completely nested loop, right? So we have to do a completely nested loop. So we have to do this shit with Y and stuff. Damn, okay, so that means we need to repeat that for Y's. I didn't think about that. X replaced with Y. All right, so it's going to be Y. And this one is going to be height. Right, and we're going to do 4. Yeah, so we'll have to repeat that stuff in here. For some reason, I didn't think that I need the second direction. I'm an idiot. Right, so, and in here, this is going to be the actual Y. Nah, it doesn't show anything. Render sprites. So we do render sprites. So maybe I did clamp incorrectly. If it's less than minimum, right? So the first thing. I'm an idiot. So yeah, that's true. That's true. Do I have to refresh that? Am I going fucking crazy? So minimum, maximum value. You're rendering. Oh yeah, right. You're right. Oh fuck. Well, I mean, that's something. All right, so that's already something at least, right? So we can work with that. So display back image data. So what if I just always do that? I mean, that should not affect anything, but so back image data. Does anybody see any errors in here? I didn't think so. Multiplied by 4. Yes. Got him. And now, the most important part. Come on, come on. Yes, look at that. Look at that. Can you see that? Z buffering, mother flipper. Z buffering. Z fucking buffering, bruv. Z fucking buffering, mate. So it's peeking out of there. Yeah, bruv. Bruv. Look at that motherfucker. It's peeking out of there. It's peeking out of the thing. That's so fucking poggers. That is so fucking poggers. We implemented that. we actually unironically implemented that. Scheiße. In 3 hours. So now we have like everything to make a game, right? So like a very basic, simple game, right? So because we can use the sprites to denote like items that you can collect, or like effects, particles, and stuff like that. So if we're going to be shooting some enemies, this is going to be the sprites. Also, enemies themselves could be these kind of sprites. So the engine is basically complete, so to speak. The engine is basically complete. So yeah, that's super cool. So let's do committee and potentially pusher, and we will be able to finally start working on a freaking game, right? So because yeah, we've been developing the game for quite some time. I mean, the engine for quite some time already. The time has come to develop a freaking game. So this stuff, I'm not sure if it's that particularly useful. So let's actually keep. So we have type. I see what's going on. Yeah, so we haven't implemented actual like images and shit. So maybe this is something that we have to do. Yeah, so let's go ahead and actually try to render an image. So do we load the images? Okay, so just a second. I need to restore everything that we have in here. So, and now if I take a look at that stuff, bruh, did I lose the changes or something? Because if well, here they are. Yeah, so everything's fine. I don't know what the fuck is going on, honestly. So, recompile. Oh, here's the funny thing. It's just in the game, in the clamp, I forgot to denote that those things are numbers. These things are numbers. The enemies could be pull requests. You need to protect your project repo. I don't understand what you're talking about. Number. Okay. Bruh. Where is the... Oh, it's because it's... Okay, so I'm already tired. Like, I'm looking at the stage changes and I'm being surprised. Where are the changes? Okay, why do they don't change? They were staged. All right, everything's fine. So, what I want you to do, I want you to actually do the rendering, right? So I want you to do the rendering of the image and shit. So render sprites. If you take a look at this thing, we have like X and Y and whatnot. We need to map all of that shit to texture coordinates. It should be really easy. So we just do tx, and basically what is that? Like, we need to map x from 0 to width, right? So, and it's going to be x minus x1, and we effectively divide that by the sprite size, and there you go. That's it, basically. So we now have the texture coordinates. Now we need to effectively, so this is more like a destination index, right? So let's call it destination P. And then we need to figure out the source thing. So we divided by sprite to map it from 0 to 1 to normalize it. But then we now need to multiply it by sprite image data width to map it to the value from like 0 to the rest of the stuff. So we can even floor this entire thing. Right, so this one is going to be math floor divided by that and multiplied by sprite image data height. Right, so we have this kind of thing. So that should give us srcp, right? So it's going to be ty multiplied by sprite image data width plus tx multiplied by 4. And essentially, instead of hard coding the color, we're taking that color from the sprite image data. Right, so it's going to be sprite image data srcp plus 0. And we're just copying all these things, including maybe alpha All right, but this one is going to be rather interesting. This one is going to be rather interesting. Okay, so let's do all of that shit without the alpha, just to see how all of that is going to be like a rectangle and whatnot. So does it compile? It seems to be compiling. So let's refresh this shit. There we go. So that's the sprite. That's the actual sprite we have. That's pretty cool. So now we need to work with alpha, right? So we can just take the alpha and let's maybe put it somewhere here. So this is going to be the alpha, so which is 3. We probably want to divide it by 255, so we can map it to 0, 1. Right, and effectively what we can do, we want to map this entire stuff. So alpha full means that it's going to be that, but then we have to add this thing with an inverse of alpha, and let's just repeat the whole thing for this thing for each and individual component in here. Right, and so this is going to be 2. So yeah, I think that's basically what we want to do. So plus, oh shit, this one is dangerous. So maybe I probably want to create a function that mixes the cores and shit. There we go. Almost. So there's something bizarre in here. I'm not really sure what the fuck is going on, but yeah. So there's like one little stripe down there, and I wonder if I can get rid of that thing by just not doing something like this. No, I can. Look at that. So yeah, I think I just overflowed a little bit. So, and also this size, the sprite size, let's actually make it like 75. Let's make it a little bit bigger. So here is the sprite. Here's the sprite we're looking at. So it has effects and shit. Right, so imagine like this thing like actually flying at you. So yeah. So the cutting of this thing is kind of weird. Right, so we have to actually slightly increase the limitation of FOV, but apart from that, I think it's fine. Yeah, so as you can see, Z buffer is working correctly. The Z buffer is working correctly. Right, so sprite animation would be also kind of cool. Right, so you just switch the thing that you're drawing, right? So maybe put the animation into a sprite sheet and just like, yeah, iterate through the frames. It's all pretty straightforward. As soon as you get all of the math nailed down, so there's something weird going on here. Oh, it's rotating. Okay. Yeah. So I got really scared away by the fact that it's rotating towards me. Yeah. So when it's too close, when it's like closer than the clipping plane, it kind of gets weird. So maybe we need to actually stop rendering it when it's too closer than the nearest clipping plane. So one of the things we can try to do actually right now. So render sprites. Where's the render sprites? So we have this sort of like SPL, which is basically the distance, right? So if it's equal to 0, less or equal to the nearest clipping plane, that's much better, I believe. Nah, it's not doing anything, but I mean, I guess that's fine. It's not that big of a deal. Not that big of a deal, but I mean, it should work. Maybe I just need to refresh it properly. But all of that is already like details. It's already details. All right, so that was a pretty productive stream today, I guess. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with the Mr. Zozin, where we're gonna start making an actual game, like with content and shit, right? So because we have already all the necessary elements in the engine, right? So we have everything. So yeah, we can start making a game. Right. Thanks everyone for watching. I love you. Mwah.